All right, number 13. So if we pull an x out of the numerator, we get x times x squared minus x minus 6. And looks like we can pull the x out of the denominator. That would be x times x minus 4. And that numerator would still factor, so we would have x minus 3, and x plus 2 would cause a negative 1x and a minus 6. So that would be correct. And over x and x minus 4 and an x. So, since these two match, we have a whole at x equals 0. And then we could reduce this to x minus 3, x plus 2, and x minus 4. So if we put 0 into this, we get minus 3 times 2 is minus 6 divided by minus 4 is positive 6/4 or 3/2. There's the whole. Determine the horizontal or slant asymptotes, if any. Since the degree of the numerator is 1 more than the denominator, we'll have a slant asymptote. And we can get that, since these cancel, we can just divide this into that. We can do it long division. Since that's a single factor, we can also use synthetic. That would be a 4. By the way, that's where the asymptote is, x equal 4. And I can put 4 into 1x squared minus 1x minus 6, and I get 1, 4, 3, 12, and this is not 0, but this is my slant asymptote, y equals 1x plus 3. Now remember the rules on this. If the degree of the numerator and the degree of the denominator are the same, then it will be a horizontal asymptote at the ratio of the coefficients. Like if it was 3x squared and 5x squared as the leading coefficients, it would be y equals 5/3 or 3/5, whichever way I said it, I can't remember now. If the degree is greater in the denominator, then it's horizontal at y equals 0. Okay, but we have a vertical asymptote, no horizontal. We have a slant one because the degree is 1 more in the numerator than the denominator. We can get it there. We could have also done x minus 4 divided into the x squared minus x minus 6. X goes in x. That would have been x squared minus 4x. Draw the line and change the signs. Add, we get plus 3x minus 6. And that would go in there 3. And so we get x plus 3. Y equals x plus 3. So we've got the whole, we've got the slant asymptote, we've got the vertical asymptote, and all the intercepts. So if I want the y-intercepts, I make x be 0. And if I put 0 in for the x, I can't put 0 in for the x because that's where the whole is, so there is none. And then for the x-intercepts, I kind of figure out how to make the fraction be 0, which means make the numerator 0. That would be 0, can't use it, 3 and negative 2. And then we could graph it if we needed. Okay? All right. 14. This says put 1 into f. Let's see, f, I'll make it bigger here so you can see it, of x is 2e to the x minus 1. G of x is x minus 2. And let's see, hang on. And then, finally, h is these points. So, put 1 into f, that'd be 1 minus 1, it's 0. E to the 0, anything to the 0 is 1. times 2 is 2. So if I start out putting in 1 into F, I get 2 out. But I take that and put it into G, and 2 minus 2 is 0. So I started with 1, got a 2, but then put it in here and turned it into a 0. So I started with 1 and ended up with 0. So that's the answer for this. Now it says put F inside of G. Put this in for the x's here. So now I get G of F of x is F put inside of G, so that's 2e to the x minus 1. That's what I'm going to put in for the x minus 2. So there's B. C says determine G of H. Well, H is only known for 1, 2, 3, 4 points. So I'm only going to be able to figure out this for 4 points. G can take anything pretty much. It's a line. So I'll put in 1 into H, and 1 according to H goes to negative 1. So then I'll put negative 1 into G, and that'll be negative 1 minus 2 is negative 3. If I put in 2, I can put 2 into H. It says it comes out 1. I'll put 1 in here, and I get 1 minus 2 is negative 1. And then I could put in 4. 4 in H makes a 3. 3 makes 1 in G. And finally, I can put in negative 1. And negative 1 turns into positive 4, and 4 minus 2 is 2. And that's what that is. The only thing we can get. Graph f of x. Okay. There's x. There's y. When x is 0, 0 minus 1 is minus 1, so we get e to the minus 1, which is 1 over e, and then times 2, so that's 2 over e. So 2 divided by e is 0.7. So I get 0.7. And so if that's 1 and 2 and 3 and 1, 2 and 3. So let's put in 1. And if I put in 1, 1 minus 1 is 0. E to the 0 is 1 times 2 is 2. So if I put in 1, I get 2. If I put in 2, I get 2 minus 1, which is 1. E to the 1 is e times 2. So 2 times 2.7 is 5.4. 5.4 something. And it's going like this, and it will eventually get closer and closer to 0. And you can always type it in and see this. Clear 2e to the x minus 1, close parenthesis. Zoom 4 might be a good graph to put it on. And went through just below 1 and went sweeping up and went asymptotically towards the x-axis. So I did that. And now determine f inverse of x. So if we have y equals 2e to the x minus 1, and to find the inverse we switch the y and x, so we get x equals 2e to the y minus 1. So first we would divide out the 2, so we're going to have x divided by 2 equals e to the y minus 1, and we're trying to solve for y. So we're going to write this in a log equation. So this would be, the log is base e, so we'll do ln to what power to take e to get x over 2. And the answer is y minus 1. And then we add 1 to both sides, so we get 1 plus ln x over 2 equals y. That's 14. And now